Thank you very much. It's so great to be back in Finland again. I think this is the fourth IglooConf, and it's the fourth time I've been invited here. So thanks a lot to everybody who's organising it and the speakers and everyone for turning up and making this so successful. So the session that I'm going to be delivering today, I'm going to be talking about durable functions. I'm going to be talking a bit about microservices, a pattern called Singletons. I'm going to be talking about orchestration, and I've also added to this that isn't in the lineup thing. That I'm going to be talking about event sourcing, which is really the mechanism which is powering durable functions. And you may have heard of event sourcing as being a pattern, and it's a nice way of being able to explore the pattern by using durable functions. So a bit about myself. I describe myself as a developer, trainer, mentor, and evangelist. I build lots of stuff. I'm most happy in Visual Studio, working and developing things. I deliver a lot of training courses. The reason I'm looking so tired is I'm currently trying to get a Pluralsight course done by the deadline, which is a lot of work. I also do lots of classroom training, focusing on Microsoft Azure, and also focusing on the emerging AI technologies. I kind of describe myself as an AI wannabe. I'm focusing a lot on artificial intelligence, because I think that that's going to be the next big thing, especially in the Microsoft development community. I work for a company in Stockholm called Active Solution, and we're about 40 consultants who develop custom solutions for our customers, very often based on Azure technologies. So we were early adopters with Azure, and we're currently using some of the Microsoft Cognitive Services in AI solutions for customers as well. I'm an Azure MVP. I've been an MVP for about 15 years, I think, starting out with BizTalk Server, and I'm really involved with the community. So we kind of compete a bit with IglooConf. We run something called Cloudburst, which we've been running in Stockholm for the past 8 years, and it's very similar to this conference. The main advantage being that Cloudburst is free to attend. We cover the speakers' costs through user group sponsorship. So if you do want to travel out to Stockholm for a couple of days in September and see something that's sort of along the same lines as this type of conference, definitely worth checking out. Also, as an experiment last year, we ran something called AI Burst, which was a one-day conference on artificial intelligence and machine learning. We had some great speakers, 2 speakers traveling over from the Netherlands, I think, and we had a few local speakers. We're doing AI Burst again. It's going to be in June. We're doing one day in Amsterdam, and then we're doing a day in Stockholm. So that's going to be a 2-day event, but with pretty much the same sessions, but in 2 different cities. Again, watch out for that. That's going to be in June. So, if you're an Azure developer, you probably will have some kind of familiarity with working with Azure functions. This concept whereby we've got this serverless compute service where we can basically create code in the cloud. We can create an Azure Functions project, we can create an Azure function, and within the Azure portal we can just basically write code. We save that function, and then that function can be executed. The code is going to run on demand, and we're going to be billed by the actual amount of time that the code has run. And functions are typically triggered by some kind of external event. And there's many types of triggers that we can have on Azure Functions. We could have an event hub, events coming on event hubs triggering functions. We could have some kind of queuing mechanism. We can use storage queues, service bus queues, topics and subscriptions. We can be triggered from things like blob storage. So when an item is loaded into a blob, we can trigger an Azure function. And this has been used, we used this in a customer project. We had a customer who was storing PDF documents in an Azure blob storage repository, and that was hosted in Amsterdam in the West Europe data center. They had a customer in the US who was wanting to access these thousands and thousands of PDF documents, and to reduce latency, we wanted to geo-replicate the data from Europe across to the US. Now, we do get geo-replication in storage. However, it's tied to the specific data center pairings that Microsoft sets up for you. So you may know that the Amsterdam data center is paired up with a Dublin data center. Stuff we store in Amsterdam is geo-replicated to Dublin. It can't be geo-replicated to America. So what we did was we basically built an Azure function which was triggered off blob storage. When a blob is created or updated in that blob storage container, it triggers an Azure function. The Azure function had about 5 lines of code in it, which would basically copy the blob from this storage account to the blob storage account in America. And we had geo-replication by just using a simple Azure function triggered off blob storage. It took us about a day to build this and get this thing into production, and it's costing fractions of €1 per month for this actual service to run. So there's many scenarios that we can use. There's a whole list of triggers that we can work with on Azure functions. It can be triggered by many different scenarios, including timers. So you can use it as a scheduled task. Run this bit of code every hour, or run this bit of code at 3 o'clock every morning, and so on. The hosting plans for hosting functions, we have a couple of different plans. We have the consumption plan. This is when you pay for when your code executes. So if you've got the function executing once a day at 3 o'clock in the morning, it's not going to be costing you too much for that actual deployment. So you're not paying dollars per hour or euros per hour for this service being present. You're only running when that code runs. The more times your function runs, the more you will pay. We also have the option of going for an app service plan. And this is when you're paying euros per hour for the actual service to be present, and then you've got the ability to run as many functions as you want. There are some scenarios where you may want to choose the app service plan, longer running functions. We typically have 10 minutes max execution time. Now, this is on regular functions. We'll look at durable functions later on and see how they can run a lot longer. They can run for several days and several weeks, and they can still run on the consumption plan. Here, we're talking about starting up a function and it's churning away doing some kind of batch job. There is a 10-minute time limit on the consumption plan. So when you're starting to work with functions, you may consider, well, I can trigger functions off an HTTP request. When should I build an Azure function, and when should I build an API? Lots of discussions on that. So typically, if you're building RESTful data operations that are going to be returning data, API is a good choice. Performing actions and being able to do other scenarios, just running code, where you're not really concerned about building REST-based services, maybe functions is going to be a good choice. So we're going to break away from Azure Functions for a bit and start talking about workflows and what kind of benefits we get from running with durable functions. So now when I'm talking about durable workflows, I'm being kind of technology agnostic. I'm just talking about the concept of a durable workflow and how it can work in many different technologies. So things that durable workflow can provide, the idea is we get some kind of workflow host, we get instances of the workflow that can be created and managed in this host. And we also get some kind of a persistence mechanism where the state of the workflows can be persisted into a data store. And this saving of state, we typically refer to it as persistence. In BizTalk land, they talk about something called dehydration, which I'll get onto a bit later on. But what we're doing is pretty much taking the state of the workflow and sticking it in some kind of durable data store. And this is where we get the name of durable functions, from the actual durability of being able to actually store the function state in some kind of a data store. BizTalk Server, one of my favorite server products from Microsoft. We have this thing called the orchestration engine, which was built around about 2004 and hasn't evolved much since then. But what the orchestration engine does is it runs in conjunction with this database called the message box database. And these orchestration instances, they're basically stored or persisted in this message box database, much the same way as we do with the durable workflows. Now, this gives us some advantages. It gives us the advantage of having durability. If the state of my workflow is stored in this data store, that means that if my host breaks, or if I restart my host, or if I decide to do an update or a patch on my host and reboot it, the state of my actual running process is going to be durable. It's stored within that durable store. So we can reboot an instance of the host, and we can recover the instance of that process. We also get the long-running nature of having these durable processes. It's not something that's running in memory. With cloud computing, the servers that they run in the data centers, both Amazon and Microsoft, typically have a 2 or 3% failure rate. So within any given calendar year, there's a 2 or 3% chance that the server could actually fail, just break, stop working. So this is why we need to think about having processes running on two servers. This is why we run things on 2 instances. And the actual process hosting our actual workflow could break. So we need to have that durability. to be able to actually bring this up again if our processes are going to be long running. So what is long running? We talked about that 10-minute limit that we had on the consumption plan. Long running could be a number of minutes, it could be a number of hours, it could even be a number of days or weeks or months. So we could be talking about calendar time in terms of long running. And we'll look at a scenario later on when we can use durable functions for a process that will run over several days. So we can basically reload or rehydrate or basically deserialize the actual state back into the process and continue running. So it could have several events that take place over this actual transaction that take place over a span of several days, and we basically load up and offload that. It gives us scalability. We can scale out our processing tier if we get lots of instances using the same data store, and the resources of multiple servers can be shared across all of those instances. The workflows that we're building do need to be process agnostic. We can't be dependent on this running on a particular physical server. So caching stuff in memory and expecting it to be there in the next execution or the next part of the execution of the workflow isn't going to be an option. So we need to make sure that we're writing code correctly so that it can execute correctly within our hosting environment. Efficient use of resources. If our processes are going to be long running and we're going to have thousands and thousands of these processes and they're going to be running for several days, we don't want to keep everything in memory. A typical virtual machine you spin up in Azure may have 7 gigs of RAM. Azure storage account, I think this slide is out of date. It says 500 terabytes on the size of an Azure storage account. I think it's larger than that now. But what it's costing you is about $2.50 per gigabyte per month for RAM in a virtual machine. In a storage, it's costing you, sorry, this is in euros, it's costing you about 5 cents per gigabyte per month. So it's a lot less expensive to have your actual state persisted in the data store. However, there is a concept of latency to think about. Reading from memory is about 100 nanoseconds. Reading from storage is about maybe 50 milliseconds. And that's about 50 million nanoseconds. So we're not going to get really, really great performance if we're persisting our instances there. It's not built for speed or performance or fast processing. It's built to give us the reliability and the durability. So a bit about durable functions and what durable functions do. We have our durable functions, and this is basically built using table storage as its actual repository. And it's basically an extension of the Azure functions and the web jobs technology. And it's focusing on building code-based workflows. So we're going to be working in C# as our preferred programming language. There are other options available. But typically, we're going to be working and doing these as code-based. The state is going to be stored in the table storage at various checkpoints during the execution of our workflow. So scenarios where we may consider using durable functions, this is typically some kind of process that we may want to build, where there's several stages to the process. We've got stage 1, stage 2, stage 3, and stage 4. And these stages are going to be executing independently of each other. And in between the stages, we're going to have some kind of a mechanism where here in this implementation, we've got a regular Azure function that basically does something. It sticks a message on a queue. Another function is going to be triggered by that queue. It's going to pick up the message, do something with it, stick it on another queue, and then there's another function, and then there's another function. And these things are chained together. Now, we could do this as just one durable function, without having to work with all of these queues, without having to work with all of this messaging, without having to write separate functions. This process could just be written as one durable function that does all of this functionality. The persistence mechanism within durable functions will handle all of the persistence and storing that state. So we don't need to worry about creating 3 queues and creating 4 functions and having this function triggered from this particular queue. That could be built as one process. Another interesting scenario is this fan-in, fan-out. We're going to call out to a number of different services. We're going to book a flight, we're going to book a hotel, we're going to book a seat on a conference. We're going to aggregate the results of these together, and then we're going to perform some kind of a commit on that transaction. And here again, this could be built just on one particular function. So that scenario there is we're going to basically make a call to an itinerary service. The itinerary service is going to get us some prices. It's going to get us the prices on the flights, the prices on the hotel, and the prices on the car hire. So we want to make this call out to multiple services, aggregate the results, and get the results back. Doing asynchronous calls, we basically start a process and then we want to basically poll this process and see what state is this process in. Has this process completed yet? Again, we could build this using queues and separate Azure functions, or we could build it using one Azure function. And another demo that I'll be looking at later on is human interaction. We're going to have some kind of approval process, expenses approval, time reporting approval, and so on. And we're going to have some human who goes in and makes the actual choice, deciding on whether to approve that or not. And that's going to be a long-running process. It's going to run for several hours or several days. Another scenario is a stateful singleton, where we're going to have one type of instance, and we're going to be updating that instance at regular items with messages that are coming in. So we could basically do things like vehicle tracking, hotel billing, with an instance for each hotel bill, and make updates to that entity there. As I mentioned previously, the background on the durable functions is a durable task framework. So this is available on GitHub. You can go in and you can play around with this code, and you can basically see how this code works. If you want to get into the depths of how this works, you can also use this within your own applications if you want to. So I'm going to run through a quick demo looking at durable functions and what they can do. And I'm going to start out by generating a new project in Visual Studio and just spinning up a regular functions project. So I'm going to do create new project. I'm going to choose Azure Functions. I have this folder called junk, which is just demos I can delete that isn't really going to be used for much. So I'll stick it in the junk folder, and I'll just functions app demo, I'll call it, and create that. Functions app demo 2. Yeah. And when we a functions, it gives us the option of choosing V1 or V2. I'm going to choose V2. And then it gives us a choice of which kind of trigger do we want. There is no durable functions trigger here. So I'm going to just select this project as being empty, and I'm going to click OK. So I've now got my empty functions project. I'm going to right-click on here. I'm going to add a new item. And that item is going to be an Azure function. And this will be durable demo. And here I'm going to choose the durable functions orchestration as the actual template for this. Now what this is going to do is it's going to kind of generate a durable function for me that is already going to go out and make a call to 3 services. I don't really like this when I'm building my own applications. I kind of want an empty, I want a clean slate when I'm building something. I don't want some kind of example of how to build this stuff. But it's nice for showing demos of what this is going to do. So the functionality here, I'll run through it at a high level and then we'll dig in a bit more depth, is to make 3 calls out to 3 different services. So it's kind of a bit like that book flight, book hotel, book conference thing. But we're saying hello to Tokyo, hello to Seattle, and hello to London. Well, let's say hello to Helsinki. Is that correct? Cool, thanks. So what we're going to do is basically call out to these 3 methods and make sort of 3 calls out to this service. Now, by default, the logging is very verbose in Azure Functions. So I kind of have this little trick where instead of logging information, I'm going to log error. And the reason I do that is the error text comes out in red. And it's easy to see against the hundreds and hundreds of lines of information text that we're going to get from the functions runtime. So I'm going to copy that. I think it was also present here as well. Log error there. 'And I'm going to run this in the functions emulator. So running this stuff on premise, it doesn't run in IIS. We get this little console application called the functions emulator, which emulates the functions environment and kicks off with a nice bit of ASCII art, which is a bit challenging to see on the projector. But what this is going to do is it's going to basically load up and host the durable function, and it's telling us that we have an endpoint available for get or post requests at this particular URL. So I'm going to copy this endpoint. I'm going to go into Postman. And this is basically a tool for just making HTTP requests and examining the results. And I'm going to send in a get URL to that particular URL. And we're going to go in here. Now, you can see why I was logging error. If I'd have done the log information, it just comes out in that blue color and gets mixed in with all of the other diagnostics text that is coming out. So the first thing that we see, this is terrible. I'll see if I can jack up the font size. So the first thing that we see here is it started the orchestration with ID, and then we've got this big long GUID. And this is basically the instance ID of that particular function execution. I'll see if I can crank it up again a bit more. So it started the orchestration with that particular instance ID. That's the instance of the durable function that is running. Then there's a bit more text here, and then we say hello to Tokyo. And then we say hello to Seattle, and then we say hello to Helsinki, and the process completes. So that's basically making those three service calls. Now I'm going to go back into this project, and I'm going to go in and just put in a bit more logging in this project here. What I'm going to do is to copy this log error here. I'm going to go in here and calling Tokyo. I haven't got my logger here, so I'm going to need my logger. So let's just take that logger from there and stick it in here. I'm just basically instrumenting this code so we can see when this code runs. So this will say start. And this will say end. And we'll run the same process again. So let's send this request again in Postman. Now this is where things get a bit bizarre. What you would have been thinking is that, well, this thing runs up, it's going to execute this bit of code here. You know, I've written the lines of code. It is going to log calling Tokyo and then say hello Tokyo. It's going to log calling Seattle and say hello Seattle. It's going to log calling Helsinki and say hello Helsinki, and then it's going to end. However, when we look at the code here, we start the orchestration instance. It says start. It says calling Tokyo. So we've got start, calling Tokyo, say hello to Tokyo. Start, calling Tokyo, calling Seattle, saying hello to Seattle. Start, calling Tokyo, calling Seattle, calling Helsinki, saying hello to Helsinki. And then we've got this calling Tokyo, calling Seattle, calling Helsinki, end. Now this is a bit bizarre, and this confused the hell out of me when I was first working with durable functions. So I'm the kind of person who does not read instructions or does not read documentation. You basically fire up something, oh, this is a new technology, let's build something with it. And obviously the first thing that happens when you try to build something with it is it doesn't work the way you expected it to work. So what do you do? You basically go in and you stick the debugger on it, and you start trying to debug it. So that's what I did with this Azure function. I basically, stuck the debugger breakpoint on here and said, well, why isn't this thing working? Let's run this and let's test it. So I'm going to send a request in. Then I'm going to step through the code in the debugger and see what happens. And we do continue. Oh, it's hit this breakpoint again. Why is it happening? Why is this thing running for a second time? Why is this thing running for a third time? What's happening? This does not make sense. So this is basically going into a bit about the internals of how durable functions work and the way that they use event sourcing. So what happens, we'll talk about this in a bit more detail later on, is it's using an event sourcing model to be able to basically reload the instance. It doesn't kind of store the actual state of the function itself. It builds up the state of the function by replaying all of the actual events that have occurred and generate that state. We'll talk in a bit more detail about how that works later on. But what we can do here is there's a couple of things that we need to be aware of if we're writing code. Obviously, if I am placing a message on a queue instead of logging error calling Tokyo, this thing is going to place several messages on the queue because it's going to run, it's going to place a message on the Tokyo queue, if I'd coded it to do that, and then it's going to run the second time, place another message on that queue, and we're going to get the code being executed multiple times. So this is why I'm doing this context call activity async here. To call these activities. It doesn't say hello Tokyo 3 times, but we do get the calling Tokyo being executed 3 times. So there's some kind of mechanism here that's preventing it from making multiple calls out to that particular external service. So the durable orchestration context has a couple of useful things on it that we can actually look at. One of them is, if I can just put some curlies in there. Context.is replaying. Now, when the replaying value is true, what it's doing is it's basically replaying through the actual functionality of this, what has executed, to build up the actual state of the function. So that's a property we'll see that changing. Also, another property that we need to be aware of is the date time. If I look at the current UTC date time versus the datetime.utc now. Why? So I'll just drop in then and then now. And I'm going to make my services a bit sleepy by dropping in a thread sleep. So let's see what this does. So we've basically run through the actual calls here. So if I go up to the top call, when we were first calling Tokyo, when that thing first executed, the replaying property was set to false, meaning that this is executing for the first time. We're not doing a replay. We're not loading up our state. And you can see that then is equal to now, 7:30 and 46 seconds, 7:30 and 46 seconds. However, when we get to the second one, the replaying property is true. We're basically replaying through the functionality of this functoid to actually build up its state. And then is set to 46, now is set to 48. So the current system time, it's basically storing the current system time when this code was executed, and also the fact that we're going through a replay operation to actually build up the state. So the reason that I'm going through and sort of banging through all of these internals of how this stuff works and what this replaying property is and this kind of mechanism is if you don't understand this and you try to build durable functions, things are going to start falling over. Things are going to start going very badly wrong because you're going to be placing multiple messages on a queue, making multiple calls. So we do need to understand a bit about that mechanism and a bit about the best practices for being able to work with durable functions. So I'll jump back to PowerPoint for a bit and just run through a bit about summarizing what was going on there. So the first thing we need to be aware of is that when we're running a durable function, we've got this thing called the durable orchestration context, which we can use to leverage and understand a bit about what's going on in the functions themselves. When we're making calls to external events, this is going to be something that is going to be useful. We're going to have to leverage this. My external event here is basically a regular function with an activity trigger. And this is what I'm going to be calling from my durable function. If I am going to be placing a message on a queue or modifying an external system or doing anything that's going to affect the outside world outside of my durable function, I have to build an activity and I have to stick that message there. So instead of sending a message to the queue in the body of my durable function, if I had written an activity called send message to queue activity and basically put the code to send a message to the queue in there, that would only get executed once, whereas the others would be executed multiple times in the actual body of the function. So it only executes this actual code here if the replaying property is set to false. If the replaying property is set to true, it will just basically build up the function state. So when we are calling our actions, we can't call external systems directly. We have to do this context.call external activity. And the context is going to be responsible for making sure that we call the external activities correctly and so on. When we are invoking our function, we're going to be using this durable orchestration client. And this is going to basically make a call to start the instance here. So what I'm doing here is basically creating the instance. I'm getting the instance ID by awaiting starter.startNewAsync. I'm passing in the name of the process that I'm going to start here, which is simple durable. I'm passing in any parameters. In this example, this is null, and I get back that big long GUID instance ID. You can pass in parameters. You can also specify your own instance ID. If you've got your kind of order ID on a particular order, you can actually create a durable function with the instance ID being the ID of the particular order, which will allow us to work with the state a lot better and identify the durable function for a particular order if we want to do that. The storage mechanism that's going to be used is Azure Storage. It uses Azure Table Storage and it uses Azure Storage Queues. We'll look at how table storage and how is basically used as the persistence mechanism later on. So I've kind of been through a bit about the durable function persistence model. I haven't demoed the persistence model. I'll just do that fairly quickly. Within the Azure Storage account, within the storage emulator, we'll get a number of tables created. And we should be able to see stuff in these tables here. So if I look at the durable functions instances, this is probably really small, but if I zoom in, we'll see that we've got these instances that have been completed in table storage saying hello Tokyo, hello Seattle, hello Helsinki, and these are showing us our instances here. We've also got the durable functions hub history here. And here we've got all of the runtime that's running through here. So for each instance, there are a number of steps or a number of events that are used to actually build up that particular instance, and all of this stuff is stored in table storage. If you're debugging, it's going to be stored in the local emulator. Obviously, if you're running in Azure, this is going to be an Azure storage account in the cloud. But you need to be aware that that storage account needs to exist there, and there is going to be a bit of billing on transactions and storage within the storage account that you are leveraging. So onto event sourcing. The mechanism that's used behind durable functions is basically event sourcing. We had a big thing at work when we were doing event sourcing, and we kind of got an expert to come in and talk about event sourcing, and we built a project using event sourcing. So quite a few of our consultants have been, basically covered in this stuff for a few months, looking at, how event sourcing system works. So there's a big interest in that within our organization. I didn't get involved in that project, but it did kind of interest me, this type of event sourcing scenario, and thinking about, event sourcing is cool. Let's think about when we can use it. So basically, it's appending to a repository of actions on objects. It's basically doing an append-only operation. We're basically writing down or storing a list of events or a list of transactions. And the actions are used to maintain or materialize the state of the domain objects. So we don't update the domain objects themselves, we just have a list of actions that take place on a domain object. And by running through those actions, we can create the state of a domain object by replaying the actions. And this basically alleviates the need for synchronization. If two processes want to update exactly the same object at exactly the same time, you can kind of get resource conflicts in some systems. However, with event sourcing, those two systems just write two different events into the event store. And we can replay those events to build up the state of the domain model. It doesn't matter. And because of that design pattern, it gives us good performance, good scalability, and good responsiveness. So the classic example of event sourcing is a bank account. You think about a bank account, and what you're concerned about is how much money is in my bank account. Well, that's the state of your bank account. It's going to be, so many euros, so many kroner, so many dollars. However, a bank account is just basically a list of transactions. You open a new bank account, there's nothing in it, there's no transactions in it. You put some money in there, and you basically stick 1,000 euros in there, so that has this one transaction of plus 1,000. You buy a few things, there's another few transactions, you get paid by your job, you get a large amount of money hopefully coming in there every month, and you buy more stuff. And from this list of transactions, by replaying that list of transactions, you can figure out what the bank account balance is. That gives us scalability. We've not got processes updating the balance continuously. We've got processes adding transactions in this append-only pattern. We can't remove transactions. We can just basically add transactions. If we find that a transaction is fraudulent, we can basically do another transaction, which will basically counteract that particular transaction. We don't remove any transactions. It's an append-only pattern. Now, because of this, because Durable Functions uses this event sourcing, we need to work with a deterministic programming. We shouldn't be writing any blocking operations. We need to ensure that we're using our durable context for all operations that are going outside of our particular function. And because of the way that this works, infinite loops should usually be avoided. Now, there are a couple of changes in functions too, with the entity type functions that can be used. But basically, if you think about this, if you get millions and millions of transactions, and you're basically building up your object state by running through all of the transactions, if you've got 1 million of them and then you add a transaction, you're going to be running through 1,000,001, 1,000,002. So you have to start your durable function, load up 1 million of these actual events to be able to get the state of your object, and then add the particular event. And so if you have just a single instance that's running thousands and thousands of times round the same loop, that's just going to get slower and slower and slower and slower. And it's not going to be a good design pattern. There are ways around that, and you can read through that in the documentation. But it's generally not a good idea. Okay, so the scenario where I'm actually going to kind of leverage the event sourcing model in the durable functions is something that I do quite often. I travel to a lot of conferences. I check into a lot of hotels. So you kind of have this process where you go up to the front desk and you check into a hotel. And then there's various things that are going to happen. You're going to basically maybe call into room service. You're going to maybe get some laundry service. You're going to stay an additional night at the hotel. You're going to, if it's in America, you're going to pay $20 a day for accessing the very slow internet. And then you've got stuff that you can take from the minibar, and then you can check out from the hotel. When you check out from the hotel, your bill is a list of transactions. The bill isn't kind of an entity that has state. What they do is they basically run through all of these transactions and basically say, okay, this, and this. And you're checking out, in America, I always say, were there any problems? And you say, yeah, the internet was slow. And says, oh, good. Well, we'll basically cross out that $20 a day, and you get $100 off your hotel bill, which can be useful. So that basically is going to be a good scenario where we can look at working with event sourcing. And that's going to result in our bill. That's going to result in our invoice. So if we didn't have durable functions and you wanted to build an event sourcing model for hotel billing, you basically start out with your business application, and then you think about what you're going to use for your event store, and your event store would kind of store all of this stuff like this, and then you'd be able to have something called a materialized view, which is going to show or present the bill to the business application. So the materialized view is going to whiz through all of the events for that particular guest ID, that particular check-in ID, and it's going to generate the actual bill by replaying those events. And you've also got external applications that can leverage the events within the event store to be able to do the various business applications. So we can do analytics on, how many guests get room service, how much do people consume from the minibar, and things like that. So that would be how you would build it in the classic sense, but we're not going to do that. We're going to build this using durable functions and see how we can create that. So I think I'll dig through the code in Visual Studio. We might come back and look at some of the actual code a bit later on, and I'll talk about what I'm doing, but I'll try and stay code focused when I look at this demo. Now, there is a Durable Functions 1.0 and a Durable Functions 2.0. We should, if you're doing File New Project, really be going for Durable Functions 2.0. So what they've done is they've made some breaking changes to the classes and the code that we use for working with Durable Functions. I'll see if I can remember what these changes are, but basically when I do File New Project in this project here, it's, I think, using the Durable Functions 1.0. So you've got this Microsoft.NET.SDK functions 1.0.29. So that's when I do File New Project. Now, that will probably change to 2.0 a bit later on. And here in the dependencies, that seems, is it the Durable Functions one that's different? Durable Task 2.10, let's see what's on here. Durable Task 182, so that's the actual change there. Now, these changes are going to break stuff, so we do need to be aware that you're going to make this choice. Are we going to go for 2.0? Are we going to go for 1.0? So the hotel billing is currently running on the 2.0, so we might notice a few changes in the way the code works. So what I've got here is the actual billing process. So this is my durable function that's going to build this kind of event source modeling for hotel billing. And just as in the other scenario, I've done some log error stuff. I've also, in host.json, and this can be a nice trick, just basically tuned down the logging. So it's not going to be spewing out tons and tons of blue text with all of these diagnostics tests. It's hopefully going to be showing me just the stuff that's relevant. So it's hopefully going to be a lot better signal to noise ratio in the logging there, and that's the change that I've made there. So back to the actual billing process. This is, I think, the first thing that I built in durable functions when I kind of wanted to explore how this thing works. So I've got my billing process, and this is using the durable orchestration context here, and I'm logging that the billing process is running the orchestrator there. Now, I mentioned that you can pass in parameters to this. So the parameter that I'm passing into this function is going to be the name of the guest. So we retrieve that from the context.getInput. That's going to be the inputs to the function, and that's going to be the name. And then there is the check-in date. Check-in date is not going to be datetime.utc now. It is going to be context.currentUTC because this thing is going to run multiple times, and every time we run it, if I use UTC now, it will be the date at which we're performing the replay, not the date when that code was originally run, when the replay state was equal to false. So that's why I'm doing the accessing the time from the context there. I then basically log that we have checked in. I then generate a new bill for the item. This is going to be for the hotel stay. The total when they've checked in is going to be 0. And then I've got a while true loop. It said avoid infinite loops. I am breaking out of this loop when they do a checkout here. So that's my basically exit from the loop here. So what I'm doing here is waiting for an external event in the durable function. The other one that I'd done where I was calling out to the 3 services didn't do this. But this is just basically going to start up, create the bill item, and then it's going to be wait for an item to be added to the bill. Now, this could take several hours, several minutes, or even several days for something new to be added to the bill, a change in the state in this process. So what will happen is it will just basically offload this thing from memory. It will be present in table storage. And when the external event comes in, it will basically reload this process, restart here, but the replay property will now be set to true. So it will go run orchestrator again. It will retrieve the name from the context. It will set the check-in date to the time when that code was originally run, when we created the instance. It will generate its new bill, and then it will get in the actual bill item that was passed in from that external event. So then it will get the date from when we're actually doing the bill item, which is going to be the current date. I'm writing some stuff out to the console. I'm adding the item to the bill, incrementing the total, and we're getting the information from the bill there. When I do checkout, then we're actually going to drop out from this function here. We're basically going to set the total on the bill. We're going to break. We're going to get down here, and we're going to return the bill. So when the first item comes in, this external event is going to be run for the first time. When the second item comes in, the second bill item, then it's going to run through again. But when it says wait for external event, it's not going to call it the external event. It's not going to really wait for that. It's just going to replay the external event and build up the actual bill from the persisted state. I've got a couple of other methods that are going to work with this actual process. I've got check-in. This is going to be the method where we're going to start the instance of the orchestration. And this is where things have broken. You can see that this is using the actual durable client. And if we go into here and look at the process that kicks off this durable demo, we're using durable orchestration client. So they've removed the word orchestration, and they've gone from durable orchestration client to durable client. And that's one of the breaking changes that they've made. So we do need to be aware. It's probably best to go for version 2 now, but that code will need to be changed eventually if you're going to upgrade from 1 to 2. So to kick off the actual process, the check-in method is basically going to create the instance there. We're going to check into the hotel. This is just a regular Azure function. But what we're going to be doing here is retrieving the name. We're then going to be starting a new instance of the billing process. And here, we're going to be passing in the name as the actual parameter to that. We're then going to say that we started the orchestration with the particular instance ID, and then that is basically going to just return the status of that. Then we want to add items to the bill. And this is where we have to basically raise an event in the existing instance of the durable function that's running. If you imagine this hotel, we've got hundreds of people staying in the hotel. One person goes in and orders room service or orders a drink to be placed on their room bill. What you have to do is to raise the event in the particular instance for that particular guest. So here you probably use the room number as the actual ID, put the drink on room 203. And what happens is then we'll basically have to route the event to that particular instance. So what I do, when I raise the external event, I specify the name of the event that I'm going to be using, which is add item to bill, which was in the billing process. This event here, it expects an object of type bill item. So I basically pass in the bill item, that's the object. And I also have to specify the ID of the particular instance. So that will say for this particular instance ID, raise the add item to bill event and send in this particular object. And that will cause it to add the item to the bill. Okay, so let's see if this check-in process works. Okay, so that should be running, and it's telling us we've got these two URIs that we can call. We've got the add item to bill, and we've got the actual check-in. So what I'm going to do is I'm going to go back to Postman, and I don't think I need this tab anymore. I've got a couple of tabs that I can use, and this one, I don't know if there's an easy way of jacking up the font in Postman, but what I'm doing is basically passing in the name of the guest, which will be Alan. And I'm going to send that in. And that is basically returning the status here. So a couple of things we can do, I'll basically zoom in on this so you can see this a bit better. Oh, Control Plus is increasing the font size there, that's good. So what we get back here is the ID of the process that we have started. And then we've got all of these query URIs, the status query URI, the send event post URI, terminate post URI. So these various URIs can be used to actually get the status of this. So if I send a GET request to this particular property here, I think. It's basically returning the status of my process. It's telling me that I have this billing process running, my instance ID, the running status is running, the name is Alan of that particular guest. So I'm able to actually query and see these instances. So this stuff is coming directly from table storage. Okay, so let's perform some operations. If I go back to this tab here, I can stay a night at the hotel, and let's put it on 119 euros or dollars or whatever it is. I need to change the instance ID, so I'm going to take the ID of this instance that I just created, drop that in as the booking ID. This is going to be as annoying as hell when somebody on the phone asks you what your booking ID is. Let's run that. So we've stayed a night at the hotel, and what we're doing here is basically starting to build up the bill from the hotel. You can see that the first time I ran it, it just said check-in is name is equal to Alan. I've just basically checked in. I've created that instance. I haven't put any transactions on that instance. So here's my first transaction. It's staying a night at the hotel. So we're building up our state by replaying these transactions. So if I stay another couple of nights at the hotel, you can see that now it's building. That was the second time I run it. Here's the third time I'm running it. So it's this event sourcing model of building up the hotel bill by replaying all of the actual transactions is really coming into play here in the way that the durable functions is working. So what I can do is go back to Postman, and we can get some drinks from the bar. And Sakari or Carl, what was the bar tab last night? Any ideas? Yeah. What's the figure? Is that NDA? Just any kind of integer. Yeah, so you can see also we're getting the state of the actual replay on here. True, 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 false on the replay. And as we go on, this is going to build up as well. So you're going to get ready and maybe stay another night at the hotel. So if I go back and drop this to, I don't know if you can Control Z here. Yeah, cool. And a true story, I was actually at a conference, and there's two Finnish guys who were in a room who were checking out, and they were checking out the hotel, and they said, is there anything, any extras, like any additional things? Have you had anything from the minibar? And they said, yes, one minibar. I don't know how much that's going to cost. Cool, yeah. So that's dropped on the minibar there. So we basically got this hotel bill here, and I'm going to also generate another guest checking in before we check out that, because you can have multiple instances running. So if I go to this one here, I should be able to duplicate this. And I've got another check-in where I can go to the body. And Jennifer, my daughter, can check in, and that generates this other instance here. And let's duplicate this one. So we've now got a couple of instances that are running on this. I'll get into this a bit later on when I talk about instance management, but we do have the option to be able to query the instances that are running. So if I run to this REST thing here, what this is doing is telling me that I've got these couple of instances of the process running, one for the guest name Alan, one for the guest name Jennifer, and it's basically showing me that these instances are running. So you are able to query these and do instance management, and the service is just querying table storage and showing you the information about the processes that are running. So back to the hotel billing and to Postman. What I'm going to do is to check out. So if I go to this guest here, I can do the checkout. I don't think it's case sensitive, but I'll try and be correct. So we have now checked out here. What we should see is that that process has now completed. And it's basically generated the actual bill from the hotel by replaying all of those transactions, and it's able to generate that entity. So that process is now complete. What we will see if we go back to the instances here is that we'll get the actual status of that process, or we should get the status of that process. So the billing process for Alan has completed, and we've got all of the items present here, and we've got the total here. So that's what that is actually returning. That's the sort of end result of that process. If I go back to Jennifer's process, you can see that one is still in the running state. So let's check out Jennifer if we can. And that should hopefully complete that process here. And back in the instances, we should see Jennifer's bill appearing here. Yeah, and then you've also got the option of being able to query for a specific instance here. So if I just query for that instance, that's just bringing back Jennifer's bill here. So on the slide, when I've kind of drawn that diagram of the application, that external applications thing here, what we're doing is we're accessing the event store to be able to work with analyzing the events in an external application. So that REST API for instance management is kind of allowing us to put that orange box on the application. We can query in and we can use the events that are present within that table storage account to be able to figure out what's been happening in the various business processes that we are creating there. Okay, so just mention a bit about the instance management. I haven't really dug in too much about this, but it allows us to start instances. We've seen how we can create a process to be able to query instances, query all instances, query instances with filters. You know, how many people checked in between January and February at the particular hotel. We've seen how we can send external events and how we can wait for completion and so on. And also, what's in preview is the option to be able to rewind instances or basically, remove transactions or do some kind of rollback. I've not explored that mechanism either, but that's hopefully going to be available and useful in the future. One thing that you may think about looking at is purging the instance history. You've got, thousands of processes. You build a big thing on durable functions. These things are running. What you may not be aware of is all of this data that's building up in your table storage table, which is going to start to maybe get expensive if you've got tons and tons and tons of it. Storage is pretty cheap. But you do want to be aware that within these, and I think because I'm in the 2.0 version, we're using the test hub name instances table here. So here we've got the 2 instances of this process that have completed, and here's the history showing all of the events that had previously run. If you're not purging this information, if you're not removing this information, then it's just going to build up there. So a couple of things. Firstly, be aware that this instance history is available and it is queryable, and it could be very useful in building your applications. You could really leverage that. Secondly, think about some kind of cleanup policy. Maybe it's only going to generate a few gigabytes of data over a 5-year window. It's maybe not going to be a problem. But if you're running thousands and thousands of these, it could generate a significant data volume. So I'm going to start to round off and talk about some technologies about where and when you may want to use durable functions. First one is logic apps versus durable functions. One presentation I'm really looking forward to is Rick's session on logic apps. I've worked with logic apps quite a bit and done some presentations, so this hopefully will be a great session looking at how logic apps can be used in real-world situations. Logic apps are JSON-based. They are very designer-centric. They have a lot more triggers than the regular functions do, but they are a bit more expensive to be able to work with, whereas durable functions are C# based. I'm very biased. There's many languages languages you can use, but we all use C#. They're very code-centric, limited in the triggers and integration that we can use, but they're a bit less expensive with running many executions. The functions team is a bit naughty when they put in, I don't know if this is still online here, Microsoft doesn't kind of, tends to frown on this type of behavior. But what they're doing is they're really putting down as our functions. They're saying now you can define workflows in code. No JSON schemas or designers needed. If you've ever worked with a JSON in the code behind in Logic Apps, it is not too pretty. So being able to avoid that and work in a pure coding environment could be a good way to go. So a quick demo on Logic Apps, just to show you kind of what they look like. I do have a Logic app here called Song Analysis. And what this thing is going to do is to analyze the text in songs and say if it is a happy song or if it is a sad song. And it's using this detect sentiment here. So I'm just going to show you quickly how this works. I'm going to copy this URL here. I'm going to go to Postman. I'm going to do a post request to this URL here. In the body, I'm going to drop in some JSON. I'm just going to check if this thing works. Yep, happy is coming back with 0.973. I think the happiest song we've ever found, Shiny Happy People by REM. That has a happiness rating of 99.3%, so that's a happy song. The saddest song we've ever found is also by REM. So let's go back here, Control Z. It's thinking about it. I don't know if these 3 dots at the end cause a problem. Oh, that got a happiness rating of 3.7% here. So what I'm doing here is I am leveraging the, I love AI. I'm leveraging the Azure Cognitive Services, and that is basically the code in the Logic app. Taking an HTTP request, fire it off to Cognitive Services, do some kind of sentiment analysis. And then just for fun, I'm also translating the lyrics into Swedish, and then using the text-to-speech and storing them in a blob. So we've got an MP3 which contains the automated voice of the translation of Everybody Hurts into Swedish, which I'm not going to play to you because it sounds absolutely terrible. Okay, so you may want to make some decisions about whether you use the durable functions or logic apps. Another technology that it kind of compares to is the durable services that we've got within Service Fabric. I see Sakurai is nodding his head there. You could build something on durable functions. You could build something on Service Fabric. I did a presentation, I think my first IglooConf, I was talking about reliable actors in Service Fabric, and I had this demo related to that. I have not touched Service Fabric since. It is complex and it is painful to work with. About every 3 or 6 months, we get a customer coming to us saying, do you know anything about Service Fabric? And we're like, why? No, maybe a bit. And says, why, what's the problem? Oh, we started building a Service Fabric project and it's all gone wrong. We need somebody to help fix it. And we're like, okay, no, sorry, we're not going to do that. We haven't really focused on this. I kind of see this as being a very complex technology. Sakura is the guy to talk to regarding that. I know he's got a lot of experience of that. But durable functions are easy. If you can build functions, you can build durable functions. As long as you can wrap your head around this event sourcing mechanism and understand that it may not do exactly what you thought it would do, and the code is going to run slightly differently. But once you can leverage that, kind of like with a hotel billing system, let's build something that is using event sourcing, following an event sourcing pattern, but I'm not going through all of the expense and research related to create an event sourcing project. Great, so thanks very much for listening. Enjoy the rest of IglooConf, and I'll be around if you've got any questions or comments on durable functions. Thank you very much.